This video is going to give some help in finding the p-value. This is assuming that you've already formulated your hypotheses, checked the conditions that are appropriate to make sure that you can use either the normal or the t-distribution, depending on what kind of parameter you're making hypotheses about, and that you have calculated the standardized test statistic correctly. So here, our first example, we're doing a test for a single proportion. Our null hypothesis is that p is equal to 0.75. Our alternative that p is less than 0.75. Our standardized normal z test statistic is negative 0.89. Now, when I want to find the p-value, what I'm going to be doing is it's a z test statistic because I'm going to be using the z, which is the standard normal distribution, to find the area beyond our test statistic in the tail or tails supporting the alternative. So since my alternative is a less than, I'm going to be using only the left tail. And so I'm going to be starting at negative 0.89. And the area to the left of it is going to be my p-value in this situation. Now to find that area, I can use technology, and I'm going to use StatCrunch. So here in StatCrunch, I'm using the calculator for the normal distribution. I'm making sure that the mean is set at 0 and the standard deviation is 1 because that's my standard normal z. And then I'm finding the area in the left tail, so I've got the x less than or equal to, and then I'm going to change the starting point of the tail to be my test statistic, negative 0.89. And then press compute. And so my p-value here is 0.1867. That is my p-value. And so that would give us weak evidence against the null hypothesis because it's a large p-value. Okay, so next up, we'll look at example 2. This one is a test for the population mean mu. Null hypothesis is that mu is equal to 100. The alternative is that mu is greater than 100. We've got a t-test statistic because we always use t when we're doing tests for a single mean. And we know the sample size is given to us as 35. This is going to be important because when I use the t-distribution, I need to specify the degrees of freedom. And I'm going to need to have n minus 1 degrees of freedom. Let's turn on my pen here. Okay, so as I'm finding my p-value, again, it's a t-test statistic, which means I'm going to use the t-distribution, which is still kind of bell-shaped, but a little bit fatter tails. And it's going to be a t-distribution with n minus 1 degrees of freedom. So 35 minus 1 gives me 34 degrees of freedom. And I'm going to be looking for the area in the tail beyond my test statistic, 2.19. And I'm going to be looking in the tail or tails that support the alternative. So the alternative is a greater than, which means larger values will support it. So this area out here is going to be my p-value. And again, I can use StatCrunch to find that. This time I don't want to use a normal calculator because I'm working with a t-distribution. So I'm going to work with my stat calculator for the t. I have to change my degrees of freedom to 34 because my sample size was 35. I'm looking for the area in the right tail, so I'm going to change this to a greater than. And I'm starting at my test statistic. What was my test statistic? 2.19. 2.19. Compute. And so my p-value is 0.0177 if I round to 4 decimal places. .0177. right? And that is my p-value. And so this one is a small p-value. It would be giving me strong evidence against the null hypothesis and in favor of the alternative that the mean is actually more than 100. Okay, let's take a look at example 3. Here we're back to a test for a proportion, p. The null is that p is equal to 0.5 versus the alternative that p is not equal to 0.5. And we've got a test statistic of negative 1.72. Now we're using a z, again, because we're working with proportions for standard normal. So again, as we're thinking about the area that's going to represent our p-value, it doesn't look very symmetric around 0. Call the 0 there. Okay. There we go. All right, so where's the area? Let's see. Well, I'm going to find my test statistic, negative 1.72, and then everything that's as far from 0 or further in either direction, since it's two-tailed alternative, right? And not equal means I'm looking not only at what's out beyond negative 1.72, but also beyond positive 1.72. This is the chance that I'd see my sample statistic or something more supporting the alternative in either direction. So again, I can find the area just in this lower tail. Because the distribution is symmetric, the area in the upper tail will be the same. So I'm coming back here. I need my normal calculator. I'm going to look in the left tail beyond my test statistic, negative 1.72. Is that what it was? Yep. And then compute. And it tells me that the area down below negative 1.72 is 0.0427. I know that this area up above 1.72 has to be the same because of the symmetry. And so my p-value is going to be 2 times 0.0427, which is 0.0854. So there's some sort of moderate to weak evidence against the null hypothesis. And one more example. This one is a test for a mean, population mean mu again. The null is that it's equal to 80. The alternative that the mean is different from 80. We've got a t-test statistic, taking the value 2.02. The sample size is n equals 50. So again, since I'm working with means, and I've calculated a t-test statistic, I'm going to be working with a t-distribution to find the p-value. The t-distribution that I'm going to be working with has degrees of freedom equal to n minus 1. N is 50, so there's 49 degrees of freedom. Here my test statistic is 2.02. So the area that's out beyond 2.02. But since my alternative is a two-tailed, I'm also looking for things that are just as far out in the opposite direction, would be providing just as strong evidence. Right, so we've got symmetric tails. And now I just need to find the area in one of those tails. So, again, stat crunching. I need my calculator for the t-distribution. I'm going to change my degrees of freedom to be 49 degrees of freedom. I'm going to find the area. I'll go with the right tail. Beyond 2.02, that was our test statistic. And then compute. I have 0.0244, the area in one tail. which means the area in the lower tail is also 0.244. And so my p-value is going to be 2 times 0.0244, which is 0.0488. And that's a moderately strong evidence against the null hypothesis and in favor of the alternative. I hope seeing some examples worked through was helpful. Thanks. Have a good day.